Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about confidence intervals for two independent means. The addition of bran to the diet has reported to benefit patients with diverticulitis. That's a mouthful. Several different bran preparations are available, and a clinician wants to test the efficacy of two of them on patients. By random allocation, the clinician selects two groups of patients aged 40 to 64 with diverticulosis of comparable severity. Sample 1 contains 15 patients who are given treatment A, and the sample 2 contains 12 patients who are given treatment B. The transit times of food through the gut are measured by a standard technique with marked pellets, and the results are recorded. For sample 1, here is our data, and for sample 2, here is our data. We are asked to construct a confidence interval for the difference in mu equals the mean transit times for food with sample 1, and mu sub 2 equals the mean transit times of food in sample 2. This is going to be a two-sample t-interval for mu sub 1 minus mu sub 2. We have random samples of 15 and 12 patients. Note that the problem actually said there was random assignment of treatments here, not random samples. So my slide should have read random assignment. The 10% condition is met for both groups. And then normality is a little bit of a pickle here. We were not told that the transit times were normally distributed as a population, and we do not have large enough samples for the central limit theorem to apply. So we need to make two box plots, one for each group. You can see here that both box plots are not necessarily symmetric, but they don't have any major skewness or outliers. So we would say the data from both samples does not show any major skewness or outliers, so a T procedure is appropriate. Now let's jump over to Desmos to see how these box plots were made and to run our interval. In Desmos, I had put the samples from the first group into X sub 1 here, and the samples from the second group into the Y sub 1. If we scroll down, you can see all the data. And this is how I coded the box plots, just box plot and then in parentheses X1, and box plot and in parentheses Y1. And here to the right, you can see the box plots. Now, when you do this in Desmos, initially it is going to have the box plots overlapping. I changed the second box plot to have an offset of 3, and that raised this red box plot up a few points on the graph so we can clearly see each of the box plots. Now, while we're here, let's go ahead and run our confidence interval. We're going to go to our inference menu, and since we're doing means, it's going to be a t-test. My first set of data is in the X1 list, so I'm going to put X1. I'm going to add in a second sample and put in Y1 for my second list and hit Create Test. Now my testing menu pops up, and I could either click on the confidence interval or significance test. Here, we're going to do a confidence interval. And you can see we're going to leave it at 95%, and we can see the difference is between negative 28.67 and negative 1.664. To wrap up my problem, I'm now going to give my conclusion. We are 90% confident that the true difference in mu sub 1 equals the mean transit times of food for sample 1, and mu sub 2 equals the mean transit times for food in sample 2, is in the interval negative 26.53 to negative 4.304. Oh, I think in Desmos I did a 95% instead of a 90%. My apologies. We should have changed the confidence level to 90%. Thank you for joining us. I will leave you with this quote by Pablo Picasso. Have a great day.